You just asked an AI a question. You watched a cursor blink for a moment. Then words started pouring across your screen, smooth and confident, like someone very smart was typing to you live from the other side of the world. But what actually happened in those 2 seconds is far stranger than a person typing. Because nothing read your question, not one word of it. The moment you hit send, your sentence was destroyed. It was shredded into pieces, converted into pure numbers, and fired through a building full of machines that have no idea what a word even is. And the answer you got back? It was assembled by a system that did not know how its own sentence would end when it started writing it. Sound impossible? It's actually not. When you tapped send, your question left your phone wrapped in encryption, which just means it was scrambled into gibberish that only one specific computer on Earth can unscramble. It hopped from your phone to a cell tower or router, into fiber optic cables, and raced toward a data center at nearly the speed of light. A data center is a warehouse the size of several football fields, packed floor to ceiling with computers, humming in the dark. Somewhere in that warehouse, your little question arrived. Total time elapsed so far? A few hundredths of a second. Now the strange part begins. The first machine to touch your question is called a tokenizer. Its whole job is demolition. It takes your sentence and chops it into fragments called tokens, which are chunks of language, sometimes a whole word, sometimes just a syllable or a piece of punctuation. The word understanding might get sliced into understand and yang, like a chef breaking a carrot into pieces the recipe can use. Your thoughtful question just became a list of roughly a few dozen chunks. Then each chunk is swapped for a number from a giant lookup table. That is it. That is all the AI will ever receive from you. Not your words, just numbers. So how can numbers mean anything? Here's the trick that makes the whole thing work. Each of those numbers gets expanded into something called an embedding, which is basically a set of coordinates like a GPS location, except instead of locating a place on Earth, it locates a meaning in a kind of map of ideas. On this map, the coordinates for king sit near queen. Paris sits near France. Angry sits near furious and far from delighted. Your entire question is now a constellation of points floating in this meaning space. The machine cannot read, but it can measure distance. And in this space, distance is meaning. This is where the real engine kicks in. In 2017, a team of researchers at Google, including an engineer named Ashish Vaswani, published a paper with a strangely confident title, Attention is All You Need. That paper introduced the transformer, the architecture behind almost every AI you have ever talked to. The T in GPT literally stands for it. And the big idea, attention, is simpler than it sounds. It means that every token in your question gets to look at every other token and decide which ones matter most for its own meaning. In the sentence, the robot dropped the glass because it was slippery, attention is how the machine figures out that it probably means the glass and not the robot. Every word cross-examines every other word, all at once, dozens of layers deep. Do you know what kind of hardware it takes to do that in real time? Your question landed on racks of processors called GPUs, chips originally invented to draw video game graphics, because it turns out the math for rendering an explosion and the math for computing attention are nearly the same kind of math, just billions of multiplications done in parallel. Companies like nvidia build the most famous ones. One company, Cerebras, got so impatient with normal chips that it builds a processor out of an entire silicon wafer, a single chip the size of a dinner plate with hundreds of thousands of cores, and in recent demos, it has pushed AI responses out at hundreds of tokens per second. Your 2-second answer is being computed by some of the most extreme hardware humans have ever manufactured. And now the machine begins to answer. But here comes the twist, and it changes how you will see every AI conversation you ever have. The model does not compose its reply the way you would, thinking of an idea and then writing it down. It generates exactly one token at a time. It looks at your question plus everything it has written so far, and computes a probability score for every possible next token. In its vocabulary, tens of thousands of options, all scored in an instant. The word "the" might get 4%, a comma might get 2%. Then the system essentially spins a weighted roulette wheel and picks one. That token gets bolted onto the sentence. And then the entire process runs again from scratch for the next token. And again. And again, dozens of times per second. Read that back slowly. The machine that just explained quantum physics to you never planned the sentence. It discovered its own answer one fragment at a time, the same way you discover the next domino falling. There is no finished thought waiting inside, no rough draft, no outline. Just an astonishingly good guess about what should come next, repeated hundreds of times until a stop signal wins the roulette spin. That is also why the typing effect you see is not a design choice to look cool. You are literally watching the answer be born, token by token, in real time. That roulette wheel also explains a mystery you have probably noticed yourself. Ask the same AI the same question twice and you get two different answers. Why? Because the spin is deliberately random. Engineers control how random with a setting called temperature, which is just a dial for how adventurous the guessing gets. Turn it down to 0 and the model always picks the single most likely token, making it predictable, careful, and a little boring. Turn it up and the wheel starts landing on less likely options, which is where surprising phrasing and creative ideas come from, along with the occasional nonsense. The same machine can be an accountant or a poet. The only difference is how hard someone spins the wheel. This idea is older than you would guess. In 1948, a mathematician at Bell Labs named Claude Shannon, the father of information theory, played a game with his wife Mary where she would guess a text one letter at a time, and he measured how predictable English actually is. Shannon proved that language has structure you can compute, that the next piece of a sentence is statistically guessable. Every modern chatbot is Shannon's parlor game, scaled up by 1 trillion times and run on chips he could never have imagined. But wait, if the model only predicts the next token, how does it remember what you said 5 messages ago? Here's the part almost nobody knows. It does not remember at all. These models have no memory between messages. Nothing carries over inside the network itself. So every single time you send a new message, the system quietly refeeds the entire conversation. Every question you asked, every answer it gave, all of it back through the model from the very beginning. It is like a pen pal with total amnesia who rereads your whole stack of letters, every letter ever exchanged, before writing each new reply. The illusion of a continuous conversation is rebuilt from 0, every single turn. That is why very long chats get slow and expensive. The stack of letters keeps growing, and in the middle of your 2 seconds there may be one more hidden decision. Which brain answers you at all? Over 3 weeks this summer, something happened that had never happened before. Within that stretch, OpenAI shipped GPT 5.6, Anthropic released Claude Sonnet 5, and Grok 4.5 went live, the first time every major AI lab had a frontier model publicly available at the same moment. And these systems now come in tiers, big expensive models and small cheap ones, with routing systems that can decide which one your question deserves. Ask something simple and you may be served by the budget brain. The price difference is real money. Some tiers cost several times more per token than others. Your question is being triaged like a patient in an emergency room in microseconds by accountants made of code. There is a cost to all of this, and you pay it in a currency you never see. Electricity. Every token generated is billions of arithmetic operations, and researchers estimate a single AI response can use several times the energy of an old-fashioned web search. Multiply that by billions of questions a day, and you understand why AI companies are signing deals for entire power plants. Your 2 seconds of curiosity is a measurable draw on the grid. Small for you. Staggering in total. So what does this mean for you, the person doing the asking? It means the confident voice on your screen is not a mind reporting facts it looked up. It is a prediction engine surfing the statistics of nearly everything humans have ever written, guessing the most plausible next fragment, one spin at a time. That is exactly why it can draft your email brilliantly and also state a wrong fact with perfect confidence. Plausible is the only thing it optimizes. True is just something plausible usually resembles. Once you know that, you use the tool differently. You let it do what prediction is spectacular at. Drafting, summarizing, brainstorming, translating, and you double-check the things where plausible and true can drift apart. Names, numbers, dates, anything you would bet money on. It also means you now see through the trick. When the answer streams onto your screen, you know the sentence is being decided as it appears. When the chatbot remembers your name from an hour ago, you know it just reread the entire conversation in a silent instant. When the reply comes back suspiciously fast, you know a router may have judged your question and sent it to the smaller, cheaper brain. None of this makes the technology less impressive. It makes it more impressive because the illusion is built from nothing but arithmetic, repeated at a scale no human can picture. Think about where your question actually went. It was shredded into tokens, mapped into a galaxy of coordinates where meaning is distance, cross-examined by attention layers on dinner plate-sized chips, and answered by a roulette wheel spinning through probability, hundreds of times in a warehouse you will never visit. All of it in about the time it takes you to blink twice. So the next time you ask an AI a question and watch those words pour across your screen, like someone typing live from the other side of the world, you will know the truth. There is no one typing. There never was. There is only a machine discovering its own answer one guess at a time, and getting so good at guessing that it fooled the entire planet into starting a conversation.